The next problem says in the network of figure the switch is initially at the position 1. On the steady state having reached, the switch is changed to position 2. Find I of t. Initially it is at switch position 1, then it will change from position 1 to position 2. For that we need to find I of t for t greater than 0. So for this we'll start with t is equal to 0 minus the switch is at this position, the current will flow, so inductor will act as short circuit in this case, and we'll find the current flowing through the inductor, which will be V by R1. So can draw the circuit for this. The switch is closed, you have R1 and this is shorted. We need to find current flowing through this I of t. This is R and this is V, so I of t will be V by R1. This is R1, so we can find I of t, that is I of 0 minus at time instant 0 minus. Then at t is equal to 0 plus, the switch will change from position 1 to position 2 and inductor will act as a current source. So for this t is equal to 0 plus, you can draw the diagram R1 and show a current source here which has value V by R1. This is R1, and now here you'll have R2 because the switch is from position 1 to position 2. So here you have the resistance R2. So R1, R2, and this will be V by R1. So I of 0 plus will again be V by R1. Now for t greater than 0, we replace it with an inductor in parallel with the voltage source. So for t greater than 0, this will be the diagram. So we'll apply KVL in the loop. So it will give me R1 plus R2 into I of t plus LDI I of t minus V by R1. This is constant, so we'll have LDI by dt equals to 0. Getting in the standard form, we'll have di by dt plus R1 plus R2 upon L into I of t equals to 0. So this is in our standard form. We have P as R1 plus R2 by L and Q as 0. So substituting in the solution for differential equations, I of t is equal to Q by P plus C e raised to minus Pt. Since Q is 0, we'll have I of t as C e raised to minus Pt. So we need to find the constant C at I is equal to 0 plus I of 0 plus is V by R1. So at t is equal to 0 plus, I of 0 plus is V by R1. So you can find C. So I of t is at 0 plus, this will be 1. So C will be V by R1. What I am doing is I am substituting t is equal to 0 plus in this equation. So this will come to 1. So C will be I of 0 plus, which is V by R1. Now I'll substitute this 2 in 1. So I'll get the final equation for I of t. This is after, this is, or you can say on substituting 2 in 1, you will get this equation. This is for t greater than 0.